The question is like this: which of the following will not be oxidized by O3? O3 is ozone. Ozone is a good oxidizing agent. Anything will get oxidized only when it is in lower oxidized state. Something in lower oxidized state will go to higher oxidized state. You call it as it got oxidized. And now we have to figure out in the given compounds which atom is in lower oxidized state so that it get oxidized to higher oxidized state. When we take potassium iodide, K plus already in the highest oxidized state, I minus, it can get oxidized to I2 0. So this can be oxidized. FeSO4, ferrous sulfate. Iron here exists in +2 oxidation state and it can get oxidized to Fe+3 with the help of ozone. Therefore, it will also get oxidized. KMnO4. Potassium here is in +1. Oxygen -2 into 4 atoms -8. -8 plus 1 is -8. When you take it out, it is +7. Manganese exists in its highest to oxidized state, which cannot be further oxidized. So this is the one which cannot be oxidized further. So this should be the option. Let us find out. This should be the option. Let us find out the other options also. K2MnO4. K2MnO4 is potassium manganate, where here it is in +2, -8. So it is -6 taken out -6 taken out +6, which can be oxidized to +7. Therefore, it can be oxidized. Cannot be the option. CrCl3. Chromium exists in +3. It can get oxidized to +6. So this can also be oxidized. Therefore, cannot be the option. For our question, C is the correct option. Here the question is pair of compounds having metals in their highest oxidized state. Let us take the options here, which is in highest oxidized state. MnO2 and FeCl3. Oxygen here -2 into 2 -4 taken out +4. This is -1 into 3 -3. When it is on the metal, it is +3. Whereas the second option MnO4 minus and CrO2 Cl2. And here oxygen -2 into 4 -8 taken out here +8. Therefore here it is in +7. Chromium oxide. Oxygen -2 into 2 -4 -1 into 2 -2. So it is -6. Chromium will carry +6 state. You can see here manganese in the highest oxidized state and chromium in highest oxidized state, because the valence electrons of chromium is 6 and manganese is 7. So this should be the option for our question. B option should be the right answer. We can check out with the third option also. FeCN6 3 minus. COCN6 2 minus. Here cyanide is -1 into 6 taken out, it becomes +6. So here iron exists in +3. -1 into 6 -6 taken out +6. So it is +4 here. So here they are in lower oxidized state because they have valence electrons of here cobalt will have valence electrons of 6. I mean to say it has valence electrons of 9, 3d9 configuration. 3D9 configuration, but it will lose cobalt 3D9, right? It is cobalt will be 3D9 4s2. I mean to say, sorry, cobalt is 3D7 4s2 configuration, total 9 electrons there. After losing here, if at all cobalt is in +4 oxidation state, it has to lose 4 electrons here, 2 here and 2 here, and then it will have 5 unpaired electrons. Finally, it is in +4 oxidation state, which is not the correct answer, because cobalt has valence electrons of 9 here, but 9 out of 9, 2 4s electrons, and at D there are 3 unpaired electrons, totally 5 electrons. So cobalt can maximum lose +5. It can lose maximum 5 electrons and can exist in +5 oxidation state, whereas here it is in +4 oxidation state. So this cannot be the option for our first question. For the second question, B should be the right answer. The question is like this. The correct statement about Cr2 plus and Mn3 plus. Cr2 plus, chromium is stable in Cr3 plus because of its D3 stable electronic configuration. Here 2 plus Cr2 plus will undergo oxidation and acts as a good reducing agent. So A option is right. Let us look out the B option. Mn3 plus. We all know that Mn3 plus is not stable, whereas Mn2 plus is stable because it will have D5 stable configuration. As we know, the valence electrons of manganese is 7. 7 minus 2 will be 5. Therefore, it is stable in 2 plus state. Even chromium the same. The valence electrons of chromium is 6. By losing 3 electrons, it will go to D3 stable configuration. This will go to D5 stable configuration. Therefore, chromium 2 plus jumps to 3 plus. Mn3 plus jumps to 2 plus, meaning it will undergo reduction and acts as a good oxidizing agent. So B option is also right. Let us look at the C option. We are telling Cr2 plus and Mn3 plus exhibits D4 configuration. Let us check it out. D configuration, we know how to calculate valence electrons minus charge on the ion. So the valence electrons of chromium is 6, charge is 2, therefore it is 4, that is D4 configuration. Here valence electrons are 7 and charge is 3 here, so minus 3 is equal to 4 D4 configuration. So C option is also right. So our A option is correct answer for this question. Here the question is the reaction which proceeds in forward direction. Let us look at the options here. It is Fe2O3 and HCl. Fe2O3 is a metallic basic oxide. It is a metallic basic oxide, reacts with a strong acid and undergoes neutralization to form salt plus water. So neutralization reaction favors forward reaction. So our answer should be A option. Let us check out with the other options also. B option. This is NH3 plus H2O plus NaCl gives rise to NH4Cl plus NaOH. Sodium hydroxide is a strong base. Ammonium chloride is a salt of weak base. In the presence of NaOH, ammonium chloride will decompose, break down into NH4 plus Cl minus. Sodium hydroxide will break down into Na plus OH minus. OH minus ions are strong, basic in nature, and they have a hunger for H plus ion. So they withdraw H plus ion from NH4 plus like that and combine with each other, forming water. And here ammonium ion will change into NH3. Na plus and Cl minus will combine to give NaCl. Therefore, this reaction is favored backward direction rather than forward direction. Let us check out third option, that is SnCl4 plus Hg2Cl2 gives rise to SnCl2 plus HgCl2. Here mercury exists in +2 oxidation state, whereas here it is in +1 oxidation state. Stannous in +4, and here stannic in +4 and stannous in +2. Stannous is a strong reducing agent and undergoes oxidation to +4 state. Why? Because stannous has 4 electrons, 4 valence electron. By losing all the 4 electrons, it gets octet configuration. In order to gain that stable octet configuration, Sn4 plus is stable and SnCl2 will undergo oxidation to +4. At the same time, in the presence of reducing agent HgCl2, where mercury lies in +2, despite a stable oxidation state, it will undergo reduction to +1. Why? Because here it will form HgCl, which will dimerize and forms Hg2Cl2, and that dimerization leads to stability. Therefore, Hg2 plus will undergo reduction to +1. So here also the reaction is favoring backward only. Now let's check the D option. CuI plus I2 plus K plus gives rise to Cu2 plus, Cu2 plus Ki. Cu2 plus is a strong oxidizing agent and oxidizes I minus to I2, and it gets reduced itself to Cu plus ion. We all know Cu2 plus is stable in aqueous medium. Despite its stability, it will reduce to Cu plus ion because Cui, where copper is in +1 state, will form a stable white insoluble precipitate. Due to the formation of insoluble white precipitate, Cu2 plus will get reduced to Cu plus ion here, and I minus being a very strong oxidizing agent, it has a tendency to lose the electron. It jumps from -1 state to 0 state, meaning it gets oxidized like that, because here it acts as a reducing agent. Actually, I minus is a strong reducing agent because I minus has extra electron. It has a tendency to lose the electron, and it will fall from -1. It will jump from -1 to 0 oxidation state. It gets oxidized to I2. Therefore, this reaction is also favored backward only, not forward reaction. So, for our question, A should be the answer. Here the question is, which of the following compounds is expected to be colored? We all know that colored substances are those which will have unpaired electrons in them. Now we have to figure out which central atom has unpaired electrons in it, so that we can find out the color of the compound. The first option is Ag2SO4. Here silver exists in plus 2 oxidation state. As there are two atoms here, plus 2 by 2, that is equal to plus 1, meaning silver exists in plus 1 oxidation state. Silver belongs to copper family Cu, Ag and Au, where they have D10 and S1 configuration, and here by losing by losing one electron they get D10 configuration. So Ag plus is in D10 configuration, does not have any unpaired electron, so this cannot be colored. Let us check second option, CuF2. Copper here exists in plus 2 oxidation state where it has D9 configuration, that is from D10 4s1 configuration. It lost 2 electrons here and gets D9, where it will have one unpaired electron in its d orbital. This way it has unpaired electron, so this should be colored. So our option should be B option. Let us check out with the third option, MgF2, where magnesium valence electrons are plus 2. It has lost all the 2 electrons, so it cannot be colored. Let us check CuCl, where copper exists in plus 1, where it will lose its S1 electron and will have D10 configuration, no unpaired electron. Therefore, even this cannot be the answer. Our answer should be B option. Here the question is, amongst the following, identify the species with an atom with plus 6 oxidation state. How to find out oxidation state? We are very much clear. First option is MnO4 minus. Oxygen is minus 2 into 4 minus 8. Take it out, becomes plus 7. I mean to say plus 8. Now manganese here exists in plus 7 oxidation state. Cannot be the option. Second one, CrCN6 3 minus. Cyanide has minus 1 oxidation state. There are 6 in number, minus 6. Take out the sphere, take it out from the sphere, plus 6. Therefore, here chromium exists in plus 3 oxidation state. Cannot be the answer. Third option, NiF6 2 minus. Fluorine minus 1 into 6 minus 6. Take it out, it becomes plus 6. Here nickel exists in plus 4 oxidation state. Not the answer. Next one, CrO2Cl2. Oxygen minus 2 into 2 minus 4. And this is minus 1 into 2 minus 2. Totally minus 6. Take it out, then chromium will have plus 6 oxidation state. Therefore, our option should be D option, having plus 6 oxidation state. Here the question is, when sulfur dioxide is passed through acidified dichromoid solution, what happens? Let us write the reaction. Potassium dichromate solution in acidic medium reacts with sulfur dioxide. Potassium dichromate solution will be orange in color solution. And what happens when they react with each other? Dichromate with sulfur dioxide in acidic medium, what happens? Potassium will convert into potassium sulfate and producing water molecule along with chromic sulfate, where you have Cr3 plus ion and SO4 2 minus ion. Here sulfur dioxide is a strong reducing agent and it will undergo oxidation to sulfate ion. It undergo oxidation to sulfate ion. when it is undergoing oxidation, dichromate, the chromium will undergo reduction from K to Cr2O7. It will undergo reduction to Cr3 plus ion, where it exists in plus 6 oxidation state, and here plus 3, it undergoes reduction. And here orange color solution, now by forming Cr3 plus ion, the solution turns green in color. It turns into green color solution. So our option here given is D option, where green color Cr2SO4 is formed. Here the solution is decolorized. No, because the solution is changing from orange color to green color here. Sulfur dioxide is reduced. No, it is getting oxidized in the reaction. The solution turns blue. No, it is changing into green color. So the option should be D option here.